So friends, in this video, we will learn about functions in calculus, and we will also go about learning the domain and range of a function, as well as how to evaluate a function from a given data and how to plot a function. So functions are used to represent dependence of one quantity on another, and its definition that it is a rule that takes certain numbers as inputs and assigns to each a definite output. So in terms of, let's understand it more specifically. So what happens in a function, like let's think function as a box. And this is a function, anything, it processes the information, there it's like a box, things happen inside this box. And whenever you give it an input, it returns to you a definite output. So for example, let's think a function as a addition function. So it takes two inputs, right? So it takes 3 as a first input and it takes 4 as a second input, and then it returns inside the function. The addition happens, so it adds a plus b. This is your a input, this is your b input, and it returns you 7, which is the answer of a plus b. So every input, whatever input you give, it gives you a definite output, a particular output for those inputs. Now function cannot is not always, it's not supposed to have always a formula. It can be as unpredictable as the weather of a particular area. So for example, there is a function that tells you the weather of each day. You send it as the input. So if you say that what was the weather on 4th of August 2024, so it will return you the weather of that day. So you can add the date in the input and it will give you a definite output of that particular day. What is a domain and range of a function? Okay, so the domain is basically the set of all input numbers. In terms of calculus, it's the set of all input numbers, and range is basically the set of all output numbers. Okay, and now the domain, which is the input, will always be independent. Will always be independent. And it will not depend on anything, while the range will definitely be dependent on what input is provided to you. Let's see it in terms of the example given above. So you see that 3 and 4, which was the input to our function a plus b, is not dependent on, you can give any number as the input to this function, so it's not dependent on any value. However, 7 is definitely dependent on what input has been provided to it. So is 3 and 4 provided to it, the answer will be 7. If it would be 5 and 5, the answer would be 10. So it's dependent on what input is given to it. So the range is always dependent on the domain. Also, the range, the output, can be identical for different inputs. So if you give 3 plus 4, it will also result in 7. And if you give 2 plus 5, that will also result in 7. So 7 is repeating, the output is repeating. However, it cannot be possible that the inputs for two different outputs can be same. So 8 can never have 4 plus 3 as the input, right? It can never have 4 plus 3 as the input, the same inputs as 7. It will always have a different set of inputs, which will result in the number 8. So one of the inputs can repeat, but both the same input cannot repeat. Different inputs may have identical outputs, but input do not repeat on any outputs. Now let's solve an example and let's try to evaluate a function given based on a data given. We have a question here. Meteorologists begin tracking a hurricane's distance at 8 a.m. on Tuesday, March 17th, 2015, as it approaches inland. They start tracking its approach when it is 350 miles away from the coast of Karachi. The table below shows the data they have recorded with time in hours and distance in miles. So we see that there is a table given us here, and time keeps increasing by 1 hour, and the distance keeps decreasing from the coast of Karachi by 25 miles. So this is 25 difference. Then you see that 325 and 300 again has a 25 difference, and same goes moving forward. Now the question asks, can they make a function to predict when it will hit the coast of Karachi? If yes, write the function and define your variables. So first we have to have variables that keeps changing. So time is one of the things that keep changing, and we define it. So t is equals to the time and d is equals to the distance. That again keeps changing from the coast. Now t is not dependent on anything. It's independent. The time keeps changing and it's not dependent on anything. So this will be our domain of the function and it will be independent. Now the distance, as it is dependent on what hour we are looking from 8 a.m. So it's dependent on the time, and that's why it's the range. And it's dependent on what time it is after the hurricane started approaching the coast. So whenever we are trying to write a function, always on the left-hand side, we'll have the dependent value. And always on the right-hand side, we have the independent value along with other constants that tell us what is the function of the dependent value on the independent value, right? So let's see. So first of all, we start with a base value here, which is 350. So at the start, the value is 350, and then the value keeps decreasing by minus 25. But every time you see from 350, the value keeps decreasing by 25 multiplied by the time that it is, the time that has passed, right? So we say 25 into the time minus 350. So 25 into the first value, as the time is 0. So it will be 25 into 0, it will become 0. And at the first r, at the 0th r, the value will be 350. And at the first r, it will be 325. And as we move forward, the value will decrease by 25 times every time, the dependent on the time. Okay. Now, the question asks, evacuation procedures for the coastal areas must be completed by the time the hurricane is 50 miles from the coast. Use your function to find out what time the evacuation will need to be completed. So we need to evaluate from the function provided, right? So the function is d is equals to 350 minus 25t. Now we know that we want to check what will be the time when hurricane is 50 miles from the coast. So now the d is 50 and we want to find the time. So whatever thing we are finding, we try to bring that particular variable to the left hand side. So we say 25t is equals to 350 minus 50, which becomes 300, and t 25t is equals to 300, and t is equals to 300 divided by 25, which makes t is equal to 12. So it means that after 12 hours from 8 a.m., the hurricane will reach 5 miles from the coast, and in 12 hours, they have to evacuate the area. Now the question asks, plot a graph of the function in the space provided, choosing your scale appropriately. Make sure to extend your graph beyond just the values in the table. So whenever we are making a graph, it's very important that we set our scale reasonably, and graphs help you predict the future values as well without actual data given, because it shows you a pattern that follows there. So we can predict the future values using the help of a function as well as graph. So first let's set our scale. So for the x-axis, we have time. So always the independent values comes on the x-axis, and the dependent value always falls on the y-axis. So here, this is our x-axis, and a dependent value is time. And this is our y-axis, and a dependent value is the distance, d. Okay, so now let's try to move on with the scale. So x-axis, we have time, and we will just set 1 unit is equals to 1 hour. And in y-axis, we can see that the value of the distance keeps changing by 25 units. You'll just say that 1 unit is equals to 25 miles. Okay, let's move ahead and mark our x-axis. So it starts from 0, then 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, and on the y-axis we will plot our miles. So 25 starts from 0, 25, 50, 75, 350, and as a base value is 350, we do not have a need to plot more than 350. So let's now try plotting our values. At the very 0th hour, the distance was 350 miles from the coast. Then at 1 hour after 8 a.m., the distance was 325, and it kept decreasing by 25 values every hour. So we'll plot it on the graph, and we have value till the 4th hour. We plot value to the fourth hour, and then we understand the pattern and draw a line. So that line will start from the 0th value and it will extend to the fourth value. And now we can see a pattern that this is a diagonal line, and we can keep extending the diagonal line till the value reaches 0. And now we can see that 14 hours from 8 a.m. the hurricane will reach to the coast. So they have to really empty everything before the 14 hours have passed. So this is how functions help you predict future values. Function helps you predict a value based on the information given. How formulas and functions help you get definite output whenever you have a set of inputs. So that's it for this video. I hope you enjoyed the video. Hope you understood the concept of functions. And if you like the video, please don't forget to press like and subscribe to our channel. And thanks for watching.